Okay, so we're factoring trinomials when a is greater than 1. So what that means is normally here where we didn't have a number, our a value was 1. Now it's going to be some number greater than 1. It could be a 2, a 5, a 20, a 25. God forbid us if it's a big number. You'll see why. But that gives us a little bit of a problem because when we break it up into two binomials, there's quite a few combinations of numbers that could go there. So we're going to narrow it down using the tools that we've already learned, that X game. And then remember when we were multiplying with the box, the area model format? We're going to revisit that, but we're going to work from the inside out. So let me show you what that means. So let's write this down. To factor ax squared. Is someone at the door? Okay, to factor ax squared plus bx plus c when a is greater than 1, here's what we're going to do. We're going to use that X game still. This is still going to be used. Except what we're going to do is we're going to take the leading coefficient, which is A, and the constant, C, and we're going to multiply them, and they go here, okay? The B value still goes here, like we did when A was 1. And then we're going to get two numbers, obviously. Let's call those D and E. So we're going to get these two numbers, D and E. And we're going to build an area model. We're going to create an area model. Oops. Be nice if I could spell it. So we're going to create an area model, and let me do that. That's just basically a rectangle. Okay. And I'm going to fill in. So I'm going to fill in ax squared here, and c goes here, right? That's just these numbers. Now the problem is what goes there? Well, this is where these come in. My answers to the X game, D and E. And it doesn't matter where they go. They're going to go here in the diagonal. But remember, they have to have the same, they have to be like terms. And what do they normally have besides the number part? X. So you can put, like, for example, dx here and ex there. Okay. And those go along the diagonal. And what we're going to do after that is we're going to factor out. So we're going to factor here. Basically factor out GCFs either vertically or horizontally. Actually, we'll do a little of both. And this is going to be your answers. So basically, we're going to do all of this to hunt for these answers, because these are going to be the factors we want. Okay. So let's just do one so you can see what this is all about. Here we go. So here's an example. So let's say we want to factor 3x squared plus 11x minus 20. Okay? So we want to factor that. We want to see what it breaks down into. We should get two binomial factors. All right? So the first thing we're going to do is multiply 3 and negative 20. Negative 60. That's going to go there. And then we want 11 here still. So we want two numbers that multiply to negative 60 that add up to positive 11. 15 and negative 4. Okay. So let's write those down. 15, negative 4. Okay. So now let's fill in the inside of the box. I'm going to do that here. So I'm going to put 3x squared here. Negative 20 goes here. Okay, I'm just grabbing those numbers, put them there. And now on the diagonal, and it doesn't matter which order they go in, I'm going to put 15x here. And negative 4x here. So it's these numbers here, right? But with the x part. They go here. And the diagonal, as you can see, is x. All right. So now, here's what we're going to do. We're going to factor out a GCF. Okay? So I'm going to take 3x squared and negative 4x. And I'm going to say, okay, what comes out of 3x squared and negative 4x? Just x. Just x, right? I got negative 4 and 3. There's nothing, no real common factor there. But I can't take an x from x squared and x. So this comes out. Okay? And now I could do the same thing here. I got 15x and negative 20. 5, right? I got an x here, but I don't have an x to give here. And 15 and 20, the greatest common factor is 5. So I just got x plus 5 there. Now, to get the top, you could just do a little reverse multiplying, right? A little division. X times something gives me 3x squared. 3x, right? X times 3x is 3x squared. And you can always check it by saying, look, what's 5 times 3x? 15x. So this is proof that I'm on the right track. I got that right. I'm going to do the same thing here. X times something is negative 4x. Negative 4. And now I can check it, right? 5 times negative 4 is negative 20. So it all works out. So basically, my two factors that I need are 3x take away 4 and x plus 5. If I multiply these together, I would get that. Okay? Any questions? So it gets a little tougher when you have, the thing is, this leading coefficient gives you a lot of combinations, and you got to narrow it down. And so this is a good way of narrowing it down, because there's a bunch of ways you can get negative 60. But when you know, okay, it also has to add up to 11, it really simplifies things. All right, so let's go ahead and do a few of these. We'll do 4 examples. We will up the rigor a little bit. Any questions though? Okay, so let's do number 1. Let's factor 6x squared plus 7x plus 20. Plus 2, I'm sorry. Plus 2. Okay. So we're going to factor that, see what it breaks up into. So I know I'm going to need a diamond problem or an X problem, and I know I'm going to make a box. So I'm going to just have these ready. Okay. So let's see if what we recall. What number goes here? 12. Okay. Very good. Remember, it's always your A and your C value multiplied together. 12 there and 7 down here. Okay. So I want 2 numbers that multiply to 12 that add up to 7. Okay. 3 and 4, 4 and 3. All right. So now we can fill in our box. What number goes here? 6x squared. It's always this number or this value, the leading term. I know that here is going to be the constant term. And then you break this up, either 4x and 3x or 3x and 4x. That's not going to matter. But they both have to have x. So I'll just put 3x and 4x. Okay? And let's factor. So I'm going to start here. I have 6x squared and 4x. What comes out? 2x. So 2x can divide out. And then 2x times something is 6x squared. 3x. Okay? And now let's see. What can I factor out here? I got 3x and 2. Just 1. If nothing comes out, right? 3 and 2, nothing comes out. They're both prime numbers. And x, and I don't have anything here. Well, just factor out 1. A 1 factors out. Okay, if nothing else factors, take out a 1. And now let's just see. 2x times 3x is it? I'm sorry. 1 times 3x is, yeah, I got that right. 1 times 3x is 3x. So 2x times what gives me 4x? 2. Let's test it out. 1 times 2 is 2. So I got it right. So I have 3x plus 2 times 2x plus 1. Okay. Any questions? All right. So I'd like you to try this one. Eight x squared, take away 11x plus 3. Okay, give it a try. Try just setting it up, and then we'll take it from there. Try setting up the diamond and filling in the box. So hopefully this is what you got. Any questions? So remember, the key is always on the diagonal. They have to have x's because they have to be like terms. And if you have negative 8x there and negative 3x there, that's fine. It all works out on the factoring. All right, so let's factor 8x squared and negative 3x. What pulls out of there? X, just x. Yeah, 8 and 3 are what we call relatively prime, right? They only have one, the factor of 1 in common. So let's take out an x. Negative 8x and 3. Same thing, right? What comes out of there? 1. Just 1. Again. Okay. So let's see. X times something is 8x squared. 8x. And you can always test by multiplying. 8x times x is 8x squared. And you can test it here. Yeah, this should be a negative 1. I forgot that has to be a negative 1. Or else this won't work. I just caught it here. Negative 1 times 8x is. So now let's try this. X times something is negative 3x. Negative 3. And let's test it out. Negative 1 times negative 3 is 3. Okay. So we got 8x minus 3. And x minus 1. Okay. Let's do 2 more. Next one's going to look a little different. So number 3. This one's not going to be a binomial, first of all, but we'll figure out what it would look like as a binomial. Let's say we have 27x squared minus 12. 27x squared minus 12. Okay, write that down. First of all, it's not a trinomial, but we'll fix that. Second of all, those numbers are kind of big. Now, there's something that I haven't been looking for that we have to look for in this one. Look at the numbers 27 and 12. Is there anything they have in common that I could factor out? Yeah, just a 3. Let's just take out a 3. Let's factor out 3. And then leave the rest of it in there. And so that would be 9x squared, right? 3 times 9x squared is 27x squared minus 4. Right? 3 times 4 is 12. Okay. Now, this isn't a trinomial, is it? But I can make it into a trinomial. This is also 9x squared. And if the middle term, the part with the linear term, as we call it, is gone, it would be 0x minus 4. Okay. So we do have a linear term in there. Whenever it's not there, it's 0 for the coefficient. So 9x squared minus 4 is really 9x squared plus 0x minus 4. Okay? So this part, let's factor it. Let's set up a diamond. And a box. Okay. So what number goes here? It's 9 times negative 4, right? Negative 36. What number goes here?
0.
Okay, the 0 goes here. Esme, come on, focus, please. All right. Any questions how I got the 0? It's because I'm looking at it as if it's a trinomial, and it would be 0x. So that's how I got the 0. Okay? So I want two numbers that multiply to negative 36 that add up to 0.
6 and negative 6.
Yeah, 6 and negative 6. Okay? So let's fill in this portion. We get 9x squared, negative 4, and then we want 6x and negative 6x. Okay? Okay, so let's factor whatever we can. 6x squared and negative 6x. I'm sorry, 9x squared and negative 6x.
Negative 3x.
Yeah, let's just pull out the 3. I think we're good with just 3x. Usually on the backside, we want to pull out a minus if we have to. So 3x here. Okay. Let's try doing it differently. Let's use this to get the top. Let me show you what that means. 3x times what is 9x squared? 3x. And 3x times what is negative 6x? Negative 2. Okay? Now let's try this. What times 3x is 6x? 2. Let's test it out. 2 times negative 2 is negative 4. So it works out. You should always try a couple combinations that you didn't do to see if it works out. And it does. So our answers are 3x minus 2 and 3x plus 2. So let's factor this out completely. We have 3. We factored that out. 3x minus 2. 3x plus 2. Yeah. All right. We're going to do one last problem. I'm going to try to fit it in here. Are you guys ready? Okay, here we go. Number 4, last one. It is 10x cubed plus 4x squared minus 6x. Yeah, okay. I like what you're doing. From now on, look at the whole thing and see, okay, is there a GCF I can pull out? And there is a 2x I can divide out of everything because I got 10, 4, and 6. I got a 2 that's common. X cubed, x squared, x. All of them have an x, so I can pull out an x. So we're going to factor out a 2x. Since I'm running out of room, I'm going to just write it underneath. I'm going to say 2x, parentheses, and then write down the remainder, whatever is left. So this would be 5x to the second, right? This times this would give me that. Plus 2x. This times this would give me that. Minus, well, 3, right? 2x times minus 3 would give me negative 6x, okay? So now I got this. Now we're going to see if this breaks up into two trinomials. So now we're going to do the X game and the box for this part. So I'm going to do that down here. I'm going to leave some room to put my final answer down here, okay? So here we go. That's going to go there. And here we go. So we're going to work with this. What number do we want up here? Yeah, it's 5 times negative 3. We want negative 15. And there we want a 2. So we want two numbers that multiply to negative 15 that add up to 2. Yeah. 5 and negative 3. Yeah, these two would work there. All right, so here we go. We want 5x squared here. Negative 3 there. And yeah, 5 and negative 3 again. Then we want 5x here maybe. And negative 3x here. Remembering that these have to be like terms. So let's see what we can pull out. Just x, yeah. Just x factors out here. Again, I'm going to use this x to get the whole top. X times something gives me 5x squared. 5x. X times something gives me negative 3x. Okay. Now, let me use this top number to get this number. 5x times 1 gives me 5x, so 1. Let's test it out. 1 times negative 3 is, so it works out. So here's our final answer. 2x, 5x minus 3, x plus 1. You multiply all this back together, you get the original one. Okay? All right. Any questions? All right. So the ones we're doing today are actually not going to be as hard as the last two, but we need to start practicing factoring completely. They're going to be more along the lines of 1 and 2. Okay?